Hi everyone. Today I will dive deeper into the outcomes of my project in the human factors in AI course, discussing how they related to my earlier design of Polaris AI. I will discuss the machine learning solution I designed from the perspectives of task analysis, user experience design, privacy considerations, and ethical considerations. In the current onboarding process for merchants on the online payment platform, the process of operation staff reviewing user-uploaded documents and assessing risk levels is highly repetitive and time-consuming. User must spend a considerable amount of time cross-referencing information and consolidating fragmented assessment results across different systems. This not only reduces the efficiency of the review process, but also adds to the mental burden of staff and may decrease the accuracy of assessment. In the current onboarding review process, operations staff conduct a thorough examinations of each document provided by the users upon receipt. This includes parsing the text content of the documents, navigating to internal and external databases for cross-referencing, such as confirming that the user is not listed on any AML blacklist. Operation staff record the assessment results of each document and, upon completion of all document reviews, evaluate whether to approve the end-user onboarding application based on comprehensive consideration of the results. We can observe that the actions performed by operation staff during the review process of user-uploaded documents are highly repetitive and cumbersome, relying mainly on the integration and analysis of existing information. As a result, considering the characteristics of ML, which is automation, prediction, personalization, and scalability, it is highly feasible to design a machine learning-based risk assessment model to streamline the review process, thus significantly improve assessment efficiency. The ML risk assessment model will utilize past historical risk assessment cases as training data, combined with internal and external databases for initial training. It will also undergo feature engineering and weight fine-tuning based on analysis from industry experts and the data team. The model will integrate and analyze user-submitted documents, calculating risk scores, and summarizing potential high-risk factors based on this analysis. As you can see, after implementing the ML model to optimize the process, operations staff will quickly identify high-risk areas in user information that require attention based on the information provided by the model. They will then reference the model results to assess the user risk level and make decisions regarding the onboarding application. Additionally, the summary of risk factors generated by the model will assist operations staff in efficiently providing feedback on rejection reasons to end user, helping them better prepare materials for submitting new applications in future. In the actual product, the user will submit PII data such as identity and financial information through a web form. To ensure transparency of the product, we will explain the necessity of collecting specific PII for evaluating the platform risk levels from various perspectives before users submit their data. For example, we will clarify the requirements of relevant regulations for conducting business and explain the compliance requirements of anti-money laundering measures. Additionally, we will explain the importance of using third-party databases for cross-referencing data to accurately and objectively assess users' risk levels. We will also list the name of the databases and service providers for reference. To avoid potential communicating uncertainty, we will summarize and visualize the impact of different high-risk factors on the rejection of the user's onboarding request in an easy-to-understand language after it is rejected. Additionally, we will display lists of relevant regulations and anti-money laundering requirements to facilitate self-review by users. Considering the high sensitivity to risk and compliance in financial-related products, it is necessary for the product to collect a significant amount of PII data to accurately assess its risk and security, such as comparing user profiles against AML blacklist. Therefore, the system will implement multiple measures to ensure the security of user PII and data privacy. These measures include collecting only the data necessary for risk assessment, anonymizing and encrypting data, managing data life cycles, managing data permissions, and ensuring the security of data storage locations. Compliance with relevant laws and regulations is also crucial. For example, the GDPR in the European Union mandates requirements such as obtaining explicit consent forms from users and granting individuals rights such as accessing to their data, the right to be forgotten, and data portability. Similarly, the CCPA regulation from USA asks to provide the right to opt out of the sale of personal information, provide notices, and subject to fines for non-compliance. In addition to those regulations, there are also others such as Canada's Personal Information Protection and Electronic Documents Act and US GLBA. So in summary, we need to strictly adhere to these laws and regulations of different locations where the product operates. And we need to make sure the physical location where we store the data are safe and secure so that we can ensure compliance and the security of user data. In addition, there are some potential bias factors that we need to carefully considering. The first is historical bias. The timeliness of data may lead to concept drift and data drift, such as changes in economic environments may impact risk assessment indicators. Therefore, we need to update training data regularly and intermittently retrain the model. Second is the representation bias. The limitation of data may result in the model's inability to objectively assess the risk levels of certain regions or population groups. Therefore, providing methods for manual intervention, such as feedback loops, is necessary to ensure the breadth and depth of the data. Additionally, the system needs regular training and data updates. The third is the measurement bias. Financial risk assessments involve significant complexity, with strong correlations between different weighted indicators, such as industry, region, and transaction volume. Therefore, we need to ensure the accuracy of feature variables through feature selection, cross-validation, and objectively adjust the weights of different feature variables. Next is learning bias. The same model may have differences in evaluating different population types. So we need to ensure the model's generality through cross-validation, algorithm comparison, hyperparameter optimization, and regularly updating model data and retraining. The last is deployment bias. We need to be aware of the possibility of model misuse, such as using model results as the sole factors for judging risk levels. Mechanisms for manual intervention and user-centered design can be used to mitigate this type of risk. In summary, it is necessary to ensure the objectivity and fairness of the model across different user groups through model performance monitoring, data lifecycle management, feature engineering, cross-validation, and regular model retraining. Additionally, mechanisms such as manual intervention and event monitoring will be applied to ensure the accountability of the model. Furthermore, we will enhance the interpretability of the model, comply with relevant regulations, display privacy consent, and provide specific reasons for the data required by the model to ensure the transparency of the product. Thank you for listening, and feel free to drop me a message if you have any questions.